thank you very much for joining us.
Thanks, Helen. Hi you all, good afternoon. Transgressive Dunefields, which I'll give you a better introduction of in a moment, are very common across South Australia and parts of Western Australia. And what's very interesting with these is that they can be very large coastal dune systems, but we know very little about how they actually form. So this talk is a little bit about an introduction to those, and then the discovery of a new transgressive dunefield that's just beginning to develop. So transgressive dunefields are broad aeolian sand deposits formed by the normal, basically onshore, oblique or longshore movement of sand over virtually anything that's standing in their path. They're largely unvegetated when active. This
Is it not?
Not working, yes. And they vary in size from quite small sheets, much like your bed sheet in that they don't have dunes on top of them, to small sand seas or very large-scale dune fields. And they're called transgressive dunefields largely because they transgress, they roll over, they translate over any terrain that's sitting in front of them.
I think you actually want the right arrow.
Excuse me.
There we go.
They can be very extensive. For example, this is a dune field, one of the largest in the world, in Lençóis Maranhenses in Brazil, and the active part of the dune field here is 23 kilometres across, and the vegetated or relic dune field here is some 90 kilometres across. So they can be absolutely massive, or they can be relatively small. This one in near Yalata, South Australia, West Australian border region, is relatively small, just a few hundred metres across. And here you can see the beach in Fordune and Nebka field. You'll see these again in other pictures. Nebka are these isolated vegetation patches that trap sand and form a little dome of dune. And then the active dune phase here, and a precipitation ridge, so called because sand precipitates or rains down to form the ridge as the dune field advances inland. There are a bunch of ways that we think they are formed, but in most cases we actually have relatively little data to know that this is true. So one of the ways is sea level change, particularly rising sea level. For example, after the last ice age, sea level rose 130 plus metres, and that kind of change would enact coastal erosion. That erosion would allow dunes to roll inland, and that way you build transgressive dunefields. But in addition, high sediment supply or shoreline erosion, coalescence of parabolic dunes, foredune, the first dune typically at the back of the beach, destabilising, perhaps an arid phase causes a decrease in vegetation cover and dunes start to destabilise and get moving, or combinations of those. I'll show you some examples. So we know from some drilling and dating we've done in New South Wales, for example, that if we look at the earliest phases here, phase number 1 of this dune field, that there's a little bit left of here, marine deposits and some dunes actually on the top here, that it was formed when sea level was about minus 20 metres below the present. So as sea level's rising, it's eroding the shore face here, dunes are destabilising and rolling landwards ahead of the rising sea level, and as sea level continues to rise, then phase number 2 is formed, phase number 3 is formed, these are eroded, and new dune field phases are formed as sea level goes up to the present, still stand roughly present level. So we know that sea level rise or transgression is a trigger for the initiation of these. Certainly all of the really big transgressive dunefields in South Australia, and these examples on the south coast in South Africa and Western Australia, are associated with very high sediment supply. So we believe that, for example, sediment is being pumped into the beach and shore face from these high energy surf zone systems, then blown onshore or alongshore to form these large scale transgressive dunefields. And of course, if the dominant wind regime is basically alongshore, then there's very little opportunity for a foredune or a vegetated ridge to grow along here, because as the dunes are migrating alongshore, they're going to swamp it and destroy it. And particularly if you're on arid coasts, then it's very easy to get transgressive dunefields because of high sediment supply in an area with low rainfall, low vegetation cover, very easy to make a transgressive dunefield. In addition, of course, if you're eroding the shoreline, as in this example in Western Australia, just south of Perth, you keep eroding the shoreline, you destabilise the dunes, they roll backwards, forming blowouts and parabolic dunes and transgressive dunefields. So shoreline erosion is probably a decent way in which you get these dunefields forming. And it's possible in some cases that parabolic dunes, that is these roughly U-shaped or parabola-shaped dunes, would expand laterally, and the trailing ridges between them, here and here and here, as shown by the yellow arrows, would slowly deteriorate, destabilise, and these perhaps individual parabolic dunes would then join up to form a transgressive dunefield. We have one example of that in Western Australia in the Zoutdorf cliffs, where you see here in this picture in 2005 a parabolic dune here and a couple of others here on the top of the cliffs from this Google Earth imagery, and by 2015 the arrow points to the same parabolic dune. You can see they've all joined up, and there's been a great deal of cliff erosion, as you see in the image above, and they're joining up and destabilising and forming a transgressive dunefield. So we know that happens on occasions. In addition, we think that just the foredune after it's built sometime slowly destabilises and or collapses over time might initiate a new transgressive dunefield phase. So you see in these two examples from different places in Northern California a blowout foredune complex, a blowout, so these erosional troughs here, and the foredune along here might slowly destabilise to this point where lots of the dune has been broken down into bits of remnant knobs. The sand has become mobile and starting to move landwards, as you see in this example. However, we have actually very few historical examples of that. So, for example, in this case, this small starting off, initiating transgressive dunefield here may have been formed by the collapse of the foredune here. This foredune's rebuilt later after this developed. And similarly here, we actually don't know that. We don't have any records of that. So there's no modern examples of how this might occur, where the foredune becomes more and more erosional, destabilises, and then starts to translate landwards. So one of the things we've been doing in our studies of coastal change around South Australia is examining the last 80 years of changes on the Young Husband Peninsula in southeast South Australia. And we know, for example, that this region was significantly vegetated in the last 80 years, principally by getting rid of grazing and also killing all the rabbits along here, which allowed the vegetation to come back. But in many parts of the world we're in a vegetation stabilisation phase as well, which allows that to happen. And then in the area to the southeast of where we were just looking, at a place near 42 Mile Crossing, which some of you may know as one of the first crossings you can get across the Coorong to the Young Husband Peninsula, so it's about 110 kilometres southeast of the Murray Mouth. Just next to that, at a place we're calling 41.5 Mile because it's 0.5 miles south of 42, there is this area we've recently discovered that has undergone phenomenal changes. So what you see here is a picture from Google Earth from January 2005 with a very significant scarp or cliffing of the dune system here. There's a bit of a foredune here, but most of this is actually older, relict, vegetated transgressive dunefield, which is now being eroded back. Scale here, 25 metres. And then so basically if we go through the historical imagery from Google Earth, here we are in 2007, the cliff is larger, the crest of the cliff or the scarp is starting to destabilise a little bit. By 2009, 2 years later, you can see that it's clearly destabilised a bunch, and in fact small sand sheets are starting to develop along the top. So sand is eroding by wind, or by aeolian processes, off the scarp and being blown back onto the top of the vegetation. The shoreline erosion rate is roughly around 3.8 metres per year between 2005 and 2009. So the retreat of that base of the cliff there is about 3.8 to 4 metres per year, which is quite high rates of erosion. By 2015, the next image, you can see we have utterly changed from this to now developing a small transgressive dunefield or dune sheet, because there's not much dunes on here yet, so it's technically a dune sheet. The cliff, the scarp, has retreated somewhat, and all of that sand has now been blown across the back, and a parabolic dune here has developed far more than in the previous picture. And we're seeing a shoreline erosion rate between 2009 and 2015 of about 2.5 metres per year. By 2018, the end of 2018, the dune field has now expanded further, and the edge of the dune field here, or the dune sheet, has migrated at about 7 metres per year, and in addition, the shoreline erosion rate in that period, in that 3-year period, was about 5 metres per year. Now remember, of course, the big 2016 storms occurred during this period, so what we're seeing is probably greater rates of erosion because of that several big storms during 2016. But you can see what we've got here, of course, is a quite dramatic change from a single cliff or scarp against an older vegetated dune field to a brand new phase of transgressive dunefield development. So this is the first actual example we have in the world where we can accurately say that coastal erosion, which of course is a good proxy for what will happen as sea level rises into the future, can produce a transgressive dunefield phase. And in terms of sort of geomorphological processes, what we see is that first we start to get scarping of the dune field, as you can see along here, and relatively near vertical to say 80-degree slopes, and the scarps collapse, of course, so every time there's a wave erosion event eating away at the base of the scarp, the dune face collapses to some degree, but also because the wind is now accelerating up over these 12 to 15 metre high dunes and scarps, it's starting to erode the seaward faces of these high gradient dunes, and so we start to see blowouts, these erosional troughs and basins develop quite quickly in the faces. And so you see here, for example, blowouts developing, in here in the cliff faces, from quite small ones and they rapidly develop into larger ones because you're getting strong wind flow acceleration up here, and the wind is essentially cannibalizing these dunes and eroding them out and blowing the stuff landwards. And as that slowly happens, then the slope retreats, as you see here, and tends to decrease in slope over time, and quite often it removes quite a lot of the dunes, especially the blowouts, as that retreats, and so lots of the blowouts disappear. You get some new ones developing as well, as you can see here, and some of those blowouts develop into larger parabolic dunes as the slope retreats, and of course that sand is then blown over the back to form the dunefield face. And I'll just show you some examples of change that we have. So LIDAR was flown across this area, the coastal area in South Australia in 2018, and that's the light detection and ranging data in which you can produce high-resolution digital elevation models, or DEMs. And so this is the same area in 2018 compared with one of our new drone surveys in June 2020, and you can see this area here became a large double blowout. This blowout here expanded from here, and this blowout here, which was developing here, started to become a large deep trough and eventually became a parabolic dune. And if we look along the coast at the same spot, here's that parabolic dune that isn't developed at this stage, but we're starting to see erosion in here. It makes a much, much deeper trough through here, and you get a nice parabolic shaped lobe coming here in the beginnings of a depositional lobe for a parabolic dune. And the sheet that's developing here has expanded considerably landwards. We're starting to get deep troughs eroded between these areas of vegetation, which are still holding at the moment but becoming remnant knobs. And we look to the back and we can see significant expansion of the dune field and thickening of the dunes, and the volume of sand that's been eroded from the front here and being delivered to the back, and of course much deeper troughs eroding through here as well as that expansion takes place. So quite remarkable rate of change in this relatively small dune field at this phase. And so then just some pictures flying around that area with our drones. So this is just recently in May 2020. You see a couple of guys here flying the drones for scale. So, it's relatively large. They're 12 to 15 metre high faces here. That's looking landwards. at the eroding dune face. This is looking along that foredune and relic transgressive dunefields that were completely stable, remember, just with a scarp in 2009, and lots of remnant knobs developing here as the plants are being rapidly eroded and destroyed by salt spray, sand abrasion and wind erosion around their bases. And then here's the larger dune sheet in April 2020, and this is looking along the back slope. So quite significant slip faces or precipitation ridges already developed on the back of these. This is the parabolic dune that's developing adjacent to the rest of the transgressive dunefield or dune sheet at the time. And if we compare, for example, January 05 picture from Google Earth, where I've tried to make it look a bit like the ones we have from LiDAR and from our June drone survey, you can see quite phenomenal change. There was a blowout already developing here, which is then here in 2018, and now sub-parabolic dune in 2018. But you can see on the top here a little bit of sand on the top of the scarp in 05, and fully developed transgressive dune sheet in 2018 and continuing to develop in 2020. And as I said, the rate of migration of this is about 7 metres per year, so that's actually very rapid development over time from no dunefield at all to quite extensive dunefield. It's only a few hundred metres wide, but nonetheless extremely rapid development of a new transgressive dunefield, thereby proving, in fact, for the first time, that if you have significant enough erosion here, and probably if the dunes are relatively high, then you can start eroding that system and create a new dunefield phase. And that's it. Thank you very much.
Thank you very much, Patrick.
Pleasure.
If you have any questions, please drop them in the chat. And indeed, we do have one straight away. Is coastal erosion considered to be evidence of climate change?
No, not directly.
No.
So it can be associated with climate change.
Mm-hmm.
For example, we've had about 30 centimetres of sea level rise since, say, 1880, 1890.
Mm-hmm.
And it might just be we've reached that trigger point where we're seeing now enough sea level rise that we're eroding the shoreline more often.
Right.
And therefore this kind of event that we're seeing here at 41.5 miles is an indication of that. But the fact is we just don't know that yet. This site, for example, has been eroding since the 70s.
Right.
So it may be just natural erosion.
Just the way that it's happening.
Yeah, and the problem is determining which of these examples we see around the world are purely driven by climate change or purely driven by shoreline erosion.
Right.
And of course it could be a combination of the both.
Absolutely, because that also presumably affects how we manage them.
Yeah.
Yeah, that makes sense. That's 7 metres a year that the dune's increasing by. Is that does that happen in a uniform manner, or is it something that kind of happens in fits and starts, like you talked about the 2016 storm?
Yeah, so it's very much related to how windy the year is.
Right.
So higher winds, more transport, lower winds, less transport. So if we have a mild year, you won't see those rates of development.
Right.
Compared to this past couple of years.
Right. And is there any point at which that would be likely to slow down? Is there any point at which the dune shape becomes kind of stable, or is that something that you think could just keep going?
Because this is cannibalising older dunes,
yeah,
it's liable to keep going.
Right.
Rather than stop. What we're seeing is vegetation destabilisation and reduction in cover here rather than the opposite. What can slow them down is as they move more into older forest, for example, or tall or acacia bushland.
Mm-hmm.
Then as the if you've got the trees here and the dune is migrating into those, they form a barrier, so it will slow it down the taller that vegetation is in terms of the rate of advance. It just take longer for them to pile up over the vegetation and kill it all.
Of course.
But that rates of migration of these things really are determined by either wind velocity or what the type of vegetation is behind the dune field that it's advancing into.
That makes sense. Cool. Another question in the chat. Has the fauna community changed in areas of erosion?
We have absolutely no idea. Unfortunately, there is nobody at Flinders that I've been able to find or work with that work on the fauna or even much of the flora in these dunefields.
Right.
My guess is that the fauna in these kind of environments is highly adapted to these kinds of changes. So the little critters that used to live out near the beach have migrated inland as the dunes have changed and made new niches and new homes and new habitats as that happens. Because a lot of that fauna is pretty adaptive to these conditions, and a lot of it is very much related to predation that moves in and out of all of these areas. So they may well be living in more sheltered environments, say near the Coorong lagoon, but are out here just foraging, especially the kangaroos, the emus, the larger fauna.
Yeah. Okay. You talked earlier about dating sand dunes, certain ones. How do you date a sand dune, given that they change so rapidly?
You've got a couple of main methods. So the old method is by carbon-14 dating. So you find anything that's carbon,
that might have been alive,
and you can get a date on that, on its age. So, for example, this dunefield, as it's migrated over that vegetated complex, some of that vegetation will be preserved under the dune.
Right.
So you could dig for it later and find it and then get a date on when that occurred if you didn't have this photography.
Right.
But that's how we date a lot of older dunes.
Right.
And then secondly, there's a dating process called OSL, which is optically stimulated luminescence, where you take some sand grains that are silica based and you can basically get an age on them. When a silica sand grain, not a quartz sand grain, not a carbonate grain, and this is mostly carbonate sands, calcium carbonate. But when a quartz grain is exposed to sunlight, it gets 100% dose of radiation. When it's buried, that radiation decays, and so we can then determine that rate of decay on a grain that's been buried,
by how long,
and we can work out how old it is.
Right.
Since it was last in the sun.
Right.
Yeah.
Cool. Another question: does the type of sand influence the extent of erosion?
There are some people who believe that the wind will transport the same size silica grain or quartz grain more easily than a carbonate grain, because a carbonate grain tends to be flat and platy. But on average, it's not really going to make much difference.
Right.
Yeah.
Cool. All right, if you have any other questions, feel free to drop them into the chat, but otherwise I just want to plug our other webinars quickly. So assuming I can get the thing to work, if you want to get in touch with us, if you have any other questions or you're watching the recorded version of this, stem@flinders.edu.au is the best way to do that. And we've got a couple of upcoming webinars as well, so if you have any students particularly interested in biology, I'd encourage them to tune into our student webinar tomorrow at 4 p.m. And then coming up in a couple of weeks' time, we've got 2 different webinars on beautiful mathematical objects and ways to teach math in a kind of aesthetically pleasing manner, which I'm really, really looking forward to. So you can register for those at flinders.edu.au/webinars. If anyone else has any other questions, now is the time to drop them in. Patrick, do you have anything else you want to add?
Well, and just remember that we have a Bachelor of Science in Coast and Oceans degree at Flinders.
Yes.
And your students, and therefore our future students, can do lots of coastal dunes, beaches, surf zones, dynamics, and associated things.
And field trips to the Coorong.
And lots of field trips to the Coorong.
Yeah, yes. Yeah, excellent. Well, thank you very much for that.
Pleasure.
Thank you all very much for tuning in. We hope that was interesting. Thanks, Patrick. And we wish you the best of luck with your teaching.
Cheers.
Cheers.